this video, we introduce the principle of superposition. We'll talk a little bit about why it's useful, and then we'll use an example, or we'll do an example to show how you apply it to solve circuits. So superposition basically says that any voltage or current in a circuit is the sum of that the voltages or currents due to each individual independent source alone. So in this example that we have here, the current I might be something that we want to solve for, and the way we could solve for it would be to say that the current I is the sum of some current, let's see, do this in a different color, so say I prime, where I prime is the current due to the 6-volt source with the 3 amp source basically set to 0, plus the current, which we'll call I double prime, due to the 3 amp source with the 6-volt source set to 0. Okay. In other words, the currents and voltages created in a circuit are the algebraic sum, or the superposition, of the currents and voltages created by each independent source. Now, this turns out to be extremely useful, but it's often used much more conceptually than to solve circuits. And my experience has been that almost every circuits text that you see treats it as if it were just a method to solve circuits. And in fact, by the time you get to circuits that are complex enough that you are tempted to use superposition, you might consider something more systematic like nodal analysis. Conceptually, it's an extremely useful idea. For example, when we design amplifier circuits, and these amplifier circuits use transistors or other solid-state devices, quite often it's useful to think of a DC biasing voltage due to a DC source, as well as an AC or signal voltage, which is due to a signal source. And superposition says that the complete output, or a complete voltage or a complete current anywhere in the circuit, will be obtained as the sum of the output due to the DC or biasing voltage and the AC or signal voltage. So conceptually, it's an extremely useful tool. It allows you to break your problem into two parts. One is coming up with a way to bias your transistors, and the other is to understand the design of your circuit in terms of the AC signals that you're interested in. So with that introduction, let's actually try to solve this circuit. Again, what we would like to know is what the value for I is. And we'll, I guess, just go ahead and try and solve it. So the first thing we need to do to apply superposition is we need to choose one independent source. We'll choose this 6-volt source as the source we're going to use to solve, and then everything else goes away. Now, to make a current source go away, so in this case, if we're going to use the 6-volt source, we want to make the current source go away. To make a current source go away, we just basically cut it out and leave an open circuit. An open circuit is something where no current flows from here to here, no matter how high the voltage across that is. In other words, I set the current source to 0. Okay, so now what we want to do then is, with our remaining 6-volt source, we'll solve for the current I prime. So if we look at this, these bits of the circuit basically do nothing. They're just wires. So I can think of a single loop circuit here, or I have a single loop circuit here, with the current flowing around this way. And in fact, I have 6 volts across this point, and then I have these 2 resistors, the 2 ohm resistor and the 4 ohm resistor, in series. So I can get then that the current I prime is going to be the total voltage, which in this case is 6 volts, divided by the total resistance, which is 2 ohms plus 4 ohms. So I prime is going to be 1 amp. Okay, well, that wasn't so bad, was it? Let's put the current source back. So we now have our current source back. And let's get rid of our 6 volt source. And to make a voltage source go away, to set it to 0, basically you replace it by a short circuit. The idea here is that the voltage across this voltage source will be 0 no matter how much current is flowing through it. So that's basically a short circuit. Okay, so now I have my 3 amps and I want to find the current I double prime. Okay, so that's the current still flowing down through the 4 ohm resistor. Okay, so I have the current actually flowing this way and back out here. You'll notice now I have 2 resistors, the 2 ohm and the 4 ohm resistor, in parallel, and so I can use a current divider to determine the current that flows through the 4 ohm resistor. And the current divider basically says it's going to be the total current, which is 3 amps, times the other resistor, 2 ohms, over the sum of the resistors. And I have to put a negative sign in front of this because I've drawn the current flowing down, but it's clear from the direction the source is pointing that the current's actually going to flow like this. Okay, so I can solve this, and I get then minus 1, oops, let's try to draw this in a way that doesn't look stupid, minus 1 amp. Okay, so this tells me then that the total current is going to be I 1 amp. Oh, here we'll draw this in the appropriate color. 1 amp plus negative 1 amps, or 0 amps. In other words, in my original circuit, the current that flows through the 4 ohm resistor is 0. And there we go. We've used superposition to solve for a current that flows through a resistor. Again, this is the sort of problem you'll see most of the time in a circuits text, but this is typically not how you're going to solve these circuits. Anytime that you're better off applying superposition, or when superposition is a viable alternative, you're probably better off just doing nodal analysis. But since a lot of engineering texts seem to have these problems, I'll do a couple other examples as well. So that pretty much wraps up this video. Hopefully it was instructive, and look forward to seeing you again.